We're gonna do a word problem. You only got a few in here. I'm gonna do a pretty straightforward one. Get your practice. We'll talk more about these in future sections. Here we go. Steph Curry. He's on the free throw line in basketball, and he's about 6'3", so I'm assuming his eyes are 6 feet above the floor. The horizontal distance of the free throw line to the basket is 15 feet. So from where the basket is to where he's standing, horizontally is 15 feet. Like no angle or anything, just flat. What is the angle of elevation from his eyes to the rim? All right. So anytime you have something like this, you just draw a frickin' picture. I've already kind of sketched something up. But this is somewhere where I need to give you more information. When I look at this and I go, well, come on. Everybody knows how tall a basketball hoop is, right? That's the piece of information that's actually left out of this. A basketball hoop is 10 feet high. Exactly 10 feet. I sometimes will forget that not everybody is an absolute sports junkie like myself. So I always like to tie them back to sports stuff, but I'll do my best to make certain that I explain anything. Like baseball is one of them that works really well for trade. We'll see more of those. So I just kind of drawn up a little sketch, a little something. There's my dude Steph down there. He's at the free throw line. You know, probably one of the best free throw shooters in the history of ever. The best shooter ever. I could go off for a long time. I love that dude. All right. So he's about 6'3", so I got his eyes there at 6 feet, right? Calling his eyes just locked in. 15 feet to the hoop. It's actually 15 feet to the center of it, but let's not stress. And then the hoop's 10 feet high. Now the question is asking, what's the angle of elevation of his eyes up to the rim? Now the angle of elevation always goes up from the parallel, or from the horizontal, I should say. So it always goes up. If we were to just make something kind of like this. This is the horizontal. This is parallel to the floor. So when we talk angle of elevation, we're talking about what is this angle right there. That's what we want to know. What's that angle right there? That's an angle of elevation. It goes up from the horizontal. When we talk angles of depression, like maybe you have a camera on a wall or something like this and it's looking at you. And it's coming down. An angle of depression would actually be the angle that's in here. From the horizontal. A depression would go below the horizontal. Elevation goes above it. This shit gets tricky and I'm going to try and trick you. With this. So make certain you don't let it happen. So what we could do is just make ourselves a little right triangle. We already know that the bottom is 15 feet. All right? And I'm pretty sure we could go find this out with just a basic freaking logic of this height's 10 feet and Steph's eyes are at 6 feet. So, you know what I mean? You know what I mean? Maybe it's the difference between 10 and 6. So, not to scale. None of my shit is to scale. So, what's the difference between 10 and 6? 4 feet. 15 feet away. And we want to know what that angle is right there. Put it as theta. Different color. Dope. How do we get that angle? What's given to us? We know the opposite and we know the adjacent. We go, you don't have to do this step, but I like writing it in. Tangent of the angle is equal to the opposite, which is 4, over the adjacent, which is 15. And you don't have to write it. You could just look at this and go, it's tangent inverse of 4 over 15. That's the angle. But I like us getting into this habit a little bit. Like, let's hit both sides of this bad boy with an inverse. Just getting used to this idea. We're going to need to do it later. And you know all the weird domain restrictions and all that weirdness we had in our inverse section? You actually don't have to stress about it here. Everything's a right triangle. It doesn't make a big difference. So there it is. We get that our theta was equal to inverse tangent of 4 over 15. But most of these problems, especially in your homework, and when I give you test, this is where you round. This is a good spot. You got your exact answer, but now we just pop it into a calculator. And I'll put this thing in degrees, right? And you could put it in radians if you wanted to. But typically we're doing one of these. Let's pop that in degrees. And I get that the theta was approximately 14.93 degrees. Here we go. There was our angle of elevation. But since it's a word problem, you answer the question. The angle of elevation. You don't have to say all the words. Is 14.93 degrees. All right. Hey, word problems. Just think about it like you're having a conversation with somebody. I mean, you could answer the question like, I don't know. This is pretty like, what is the angle of elevation from his eyes to the rim? Like 14.93 degrees. It sounds like a pretty reasonable answer, but a lot of teachers are going to want you to say more. Like, just like at least something. Be like, the angle of elevation is. I don't know, you ain't got to go through the angle of elevation from his eyes to the rim. If he's 15, you don't got to go through all that bullshit. But with me, just if you got a word problem, just give me a short little sentence. Just show that you know what you're talking about. Because sometimes, you ever done this and it's asking you to find the angle, or you're going to find something and then you solve for the wrong thing where you're like, all right, so 70 feet is the angle. You're like, wait a second. I've got something weird. So just by writing this out, it's just a quick check to see if we've lost sight of what the word problem actually is. Dude, that's happened to me numerous times where it's like, oh shoot, those units don't match up. I'm a silly person. Write a little sentence. I know habits in the homework where we just punch stuff in occur, but we're going to need to do writing portions, and it's going to be a lot more writing on this next exam. So let's get our practice. So there's the whole problem. I will see you in chapter 2, my favorite stuff. Oh, it's going to be good.